Welcome back to Chemistry 5070 and 0620. Today I am going to start with organic chemistry. Welcome back. So sorry for gap. Due to busy schedule, I was not able to upload videos. Now inshallah I will be uploading day by day. Please follow me. Okay. So what is organic chemistry, right? So organic chemistry is the study of organic compounds. Now what are organic compounds? Organic compounds basically are the compounds containing carbon as a major element. When we say major element, mean basically carbon is acting as a backbone of organic compounds. So other concept of organic compound is hydrocarbons. It can be hydrocarbon and their derivatives. Derivatives mean, for example, we have methane gas, CH4, right? Either this is methane gas. If we react this gas with chlorine, we will be having a product CH3Cl. Now this compound is a derivative of methane. We will discuss this one inshallah in coming lectures. So let's make this first lesson of organic chemistry easy, right? So organic compounds are the hydrocarbons and their derivatives. So what are derivatives? I told you, right? This is basically methyl chloride or chloromethane. Okay, so hydrocarbons, they are made up of only two elements. One is carbon and other is hydrogen. No other element is there. So hydrocarbons are the compounds containing carbon and hydrogen only. Now if this question is of 2 marks, right? So the word in this, the word only is, carry second mark. So you must keep in mind organic hydrocarbons must be uh, containing carbon and hydrogen. Along with this, you have to add only. Okay, there are two main types of hydrocarbons. One is saturated, other is unsaturated. There is third one, that is polyunsaturated, but polyunsaturated and unsaturated both comes under the same categories, right? Okay. So when we have saturated hydrocarbons, in case of saturated hydrocarbons, there must be carbon to carbon all single covalent bonds. So if we draw a long chain of carbon like this, there should be all carbon to carbon single covalent bonds. Okay, so all alkanes are saturated. So all the alkanes, they have carbon to carbon single covalent bonds. We will study the homologous series of alkanes later. Then we have unsaturated hydrocarbons. When the word comes unsaturated, that means there must be we are talking about double covalent bond. So unsaturated hydrocarbons, they must contain at least one carbon to carbon single covalent bond. There can be more than one, but if they are more than one, then we will be calling it as polyunsaturated, right? Hope you understand. If you have any question, you can write in the comments. Okay. And now, if we are talking about unsaturated hydrocarbons, so in these unsaturated hydrocarbons, we have alkenes. So when we see the alkenes, that means it can be ethene. Now ethene, just like ethane, the first member is methane. Here we cannot say as methane, because in methane there is only one carbon. Okay, so for uh, double covalent bond, we must need at least two carbon atoms. That is why the first member of alkenes you will see in later lessons. Uh, the first member of alkenes is ethene, so that we can show double covalent bond like this. Okay, hope you understand. Okay, so after this we have polyunsaturated hydrocarbons. So first are saturated, then unsaturated. Now we have polyunsaturated. Polyunsaturated hydrocarbons are, unsaturated basically, but they have more than one double covalent bond. When we are talking about more than one double covalent bond, then you can see uh, we are talking about uh, carbon to carbon, more than one double covalent bond. This is one double covalent bond. This is second double covalent bond. As you know that there are each carbon has four valencies. It can make only four covalent bonds. That is why we cannot show more than one double covalent bond between two carbon atoms. Hope you understand. For example, this is a member containing a member of hydrocarbons. It contains four carbon atoms. Uh, when even it has four carbon atoms, you know that the four carbon containing member of hydrocarbon is known as butane. But this is alkene because it is unsaturated. That is why we will call it as but 1,2-diene. Di mean two. This is for double bond, ene for alkene because it is unsaturated. 1 and 2, when we will study then how to number these, name these organic compounds rules a little bit. As in O levels, we do not need to know so many detailed uh, rules for naming these compounds. So this is simple member but 1,2-diene. Di mean two, 1 and 2 mean the first carbon has double bond after this, and we have third carbon after this we have double bond. So this will be, sorry, this will be 1,3-diene. Now, up till now, we have talked about what is organic chemistry, what is organic compound, what are types of organic compounds. After that, we have talked about hydrocarbon, and then types of hydrocarbons, saturated hydrocarbons, unsaturated hydrocarbons. So in case of polyunsaturated hydrocarbons, you see we have more than one double covalent bond. It can be triple covalent bond as well. Right. Now, very important topic, that is homologous series. What is homologous series? Homo means same, logos means thought. A series of organic compounds. It does not cover only hydrocarbons. It also covers other organic compounds. When I say other organic compounds, you will see by the reaction of these hydrocarbons, we will be preparing new organic compounds which will be known as derivatives, mean they have been derived from hydrocarbons. Okay, so homologous series, basically it is a series of organic compounds in which two consecutive members which come side by side. Two consecutive members differ by one carbon and two hydrogen atoms, that is CH2. So the difference of two hydrocarbon members of a series will be having one carbon and two hydrogen. You will see later when we will make series of alkenes. Let's see, I can tell you this. The first member is methane. The next member, just add one carbon. I told you all the members in a series have same uh, sorry, a series of organic compounds in which two consecutive members differ by one carbon and two hydrogen atoms. See, this is one carbon. Now we will add one carbon, it will be two. Then we will add two hydrogen, it will be six. Then we will be having C3, we will be having C8. So this process goes on, right? So you see the difference between these two members, or these two members, is of one carbon plus two hydrogen atoms. Same is here, and this process goes on. So this is homologous series. Okay. Second, characteristics of homologous series. Oh, sorry, characteristics of homologous series. All the members in a series have same general formula. Uh, Due to general formula, we can uh, deduce the formula of all the members. For example, alkanes, if we are talking about, its general formula is CnH2n plus 2. Mean if we have carbon 2, carbon number 2, if we put this one, right, C2 here, then 2 into 2, 2 here, plus 2, it will be 6. So C2 double of 2 is 4 plus 2, you will get hydrogen 6. Similarly 3, C3 multiply it with 2, mean 2n, then add 2, it will be 8. Mean the hydrogen number will be the double of carbon number plus 2. Hope you understand. This is basically methane, ethane, propane. We will study these formulas, don't worry. So I'm just telling you what is how the members differ by one carbon and two hydrogen atoms. Hope it is clear to you. Okay, so the first characteristics of homologous series is all the members in a series have same general formula. For example, alkanes have CnH2n plus 2. Alkenes have two hydrogen less than alkanes. That is why it is CnH2n. You can see this. This is alkenes general formula. Hope it is clear to you. Next, characteristics. Uh, 1 minute, please. We can remove this. I think we are unable to remove this. Okay. See this. All the members in a series have similar chemical properties. So first characteristics was all the members have in a series have same general formula. All the alkanes have CnH2n plus 2. All the alkenes have CnH2n, etc. We have other, organic compounds whose general formula is there. For example, alcohols, carboxylic acids. We will when we will study their characteristics, then we will write their general formula. Now, physical properties change gradually down the series. This is the third characteristics of homologous series. If we see according to exam point of view, this question can be of 2 to 3 marks, especially characteristics. Each characteristics carry 1 mark, but at the same time, there is a one compulsory MCQ on the basis of these general formulas. Hope you understand. Okay, boys? Okay. Then all the members in a series have same functional group. Now, what is the functional group? Functional group basically it is an atom or group of atom that gives properties to a molecule. Properties to a molecule. Hope you understand it. For example, if there is double bond, the reaction will be different. If there are all single bond, the reaction will be different. If single bond, there will be substitution reactions. If double bond, there will be addition reaction. We will study these reactions, inshallah, after in coming lessons. Uh, so it can be an atom or group of atoms that changes the properties of a molecule. If there is OH, it will become alcohol. If there is halogen, it will become alkyl halide, but alkyl halide name will be taken in A levels. Hope you understand. So there are, I told you, four characteristics of homologous series. So what were those? The first was all the members in a series have same general formula. Second, all the members in a series have similar chemical properties, combustion, all the chemical properties mean reactions. Their physical properties change gradually, mean, for example, if we have melting point or especially boiling points, there is no regular, trend in melting point because of the intermolecular forces. Um, there, as we go down the, group, their boiling point increases because of increase in intermolecular forces. Now, boiling point is physical property. Please don't mix physical property with chemical property. Chemical property means, sorry, chemical properties mean reactions. All the members of in a series have same functional group. All the alcohols, hydroxy compounds have OH attached with them. For example, you see CH3OH. This is methanol. Mean methyl alcohol is, or methanol in, we write as methanol, not methyl alcohol. This is general name. Uh, okay, we don't usually use general name. Is that clear? Okay, if you have any question, please you can ask me through the comments. If you want improvement here, I will be ready to listen to you. And inshallah, you will see at least more than 20 years past papers will be solved through the videos, inshallah, right? So stay with me, be patient, and inshallah, I will be ready to help you anywhere. Please, your comments are always welcome. I need positive comments so that I should get motivation to support you people. Thank you very much. Allah Hafiz.